Okay guys, so here we are, continuing in section 3.2, arguably the very best section in the entire textbook, entire course, my favorite, certainly one of them. We're going to talk about residuals. So I want you to take this page, okay, and I want you to flip it over, because I left some space for it. I don't know why it's on that side, but, you know, whatever. That's where I want you to take these notes. These are extra notes, okay? These are extras to help you understand it. We'll come back and look at this after. That's going to be easy when we get to it, okay? So, residuals, okay? What is a residual? Well, I want you to think we're using that same example where this is someone's homework average and this is someone's test score, and we're using the homework average to predict the test score. And if we remember the equation, the predicted test score was equal to 10 plus 1.2 times the homework average. Okay, so that's what we're still working with. Okay, and what I want you to think about is I want you to think about the graph. Now, let's make a quick sketch of this graph. Okay. The intercept is 10 and my slope is 1.2, so it's positive. So it should have a positive association. So I wouldn't draw my line this way, okay, because it's going to be a 10. So I want my dots to represent that. So I'm just going to put some dots here, okay? And we're going to have our line go through, and we're going to use that as what we think is a prediction, like a guess for what our regression line would be. Now, what a residual is the part that the line misses, okay, for its prediction. So if I look here, and I look at this point, and I look at this point, and I look at this point, they have all these little distances here, these vertical distances between the point and the line, okay? And those vertical distances are called residuals. That's what that is. That is a residual, okay? So in this situation with this problem, think of a residual, okay? Residual, what does residual look like? What word do you see there, okay? You see kind of like residue, okay? And that's what it is. So picture Smitty, scary thought as it might be, picture Smitty, and you picture him digging into a hamburger, you know? He's taking a nice big bite of a hamburger. And I don't know if you've seen him eat. Kind of like, a little bit like a caveman. We love him. We love the guy. He's a good guy. He's a good guy. But when he eats it's not always a pretty sight. So when he sits there and he digs into his hamburger, he's got the grease and stuff in the corner of his mouth. You know, that little stuff that maybe part hamburger, part grease, the residue. That's what a residual is. It's the leftover part. Okay, he got the hamburger in his mouth, and that little extra part, that little residue, that's what it is. It's a residual, okay? It's a residual. Now, if I'm thinking of this, my homework average, I'm going to say that the homework average is 50. I'm going to say the test average is 70. I don't think we're going to use this much in this particular section, okay? And this is my standard deviation of X. We're going to get into this. We are going to get into this, okay? But maybe not yet, okay? Maybe not yet. But we want to find out what these residuals are, okay? The distance between the point and the prediction, okay? And you know, that's what it is. It's the vertical distance to the least squares regression line. So let's think of two people, okay? And I'm going to use two names of people that are not in our class, Tom and Will. So let's say Tom had a 40 homework average, and then he had a 65 test average. Again, my X is homework average, my Y is the test average. And then we have Will, okay? And Will had a 70 for a homework average, 2 slugs here, okay? We're talking 2 slugs for sure. 70 for a homework average and an 82 for a test average, okay? And we want to find out what the residual is, okay? We want to find the residual. So there's a formula for the residual, okay? The formula for the residual is just like the class, okay? What class is this? This is AP. So the formula for the residual is A minus P, AP. Okay, where A stands for your actual value and P stands for your predicted predicted value. Okay, so I'm using this same equation. Here's my least squares regression line. Okay, I've got y equals 10 plus 1.2 times x. We already know what y is. Y is the predicted test score. I'm going to keep writing it, okay? Predicted test score, and x is the homework average. Okay, so when we do this, we're going to take 1.2 times x. Okay, so I have 1.2 times my x, and my x, we'll do Tom first, okay? Let's do Tom, and Tom's x is 40, so I do 1.2 times 40, and that gives me a 48, okay? 1.2, that's 40. 1.2 times 40 is 48, all right? And then I have to add 10, so I get plus 10. So for Tom, okay, his predicted value is a 58, but when he did it, he got a 65. So we do actual minus predicted. So his actual score is 65, that's the actual, minus the predicted, which was a 58. So his residual is a 7, okay? He had a positive residual. So if we're looking at the line here, if he had a positive residual, that would mean that his residual, his point is above the line. His point is above the least squared regression line, okay? And what happened? The model predicted he should have got a 58 when he actually got a 65. So the model under predicted, okay? The model said 65, he said 58. Okay? That's the first part. Now let's do it for Will. Okay, well, good old Willie here. Willie's doing a little bit more homework. We appreciate Will. Tom, I'm not too pleased with if he's pumping in with a 40 homework average. He probably wouldn't pass. He probably wouldn't have a 65. The guy's probably going to fail. And he deserves it. If he gets that, he deserves it. You don't think I'm sweating that, do you? So y hat equals 10 plus 1.2 times x, where this is predicted. See, I keep writing this out. My handwriting's horrible, but I keep writing it out so that you guys know that this isn't good enough. You have to have the predicted test score. And this is my homework average. So you don't forget to make that mistake in a quiz. Someone's going to do it, okay? Someone's going to do it, and I don't want it to be you. So, all right. So we have Will, right? And Will had a 70 and an 82. So he had a 70 for a homework average, and you get 82 for a test average. So let's see what this model does for Willie. So we've got 10 plus 1.2 times 70. So we go to our old calculator and we type in 1.2 times 70 and I get 84. Okay, and then I've got to add 10 to that and it's going to give me a 94. So the model says he should have got a 94. He only got an 82. So we do actual minus predicted and that gives me a negative 8. So what does that tell me? The model over predicted. Okay, he should have got a 94 and he only got an 82. Okay, so the model over predicted. So one other problem with these residuals, let's say we had this. Let's say that Joey had a residual of negative 8. His homework average was 60. What is his test average? So again, we do, our A minus P has to equal a negative 8. Okay? And if his homework average is a 60, we got to find out what the model predicts for that. So I do 10 plus 1.2 times 60. Okay? And 1.2 times 60, 1.2 times 60 gives me a 72. and 10 is an 82. Okay, so this is what he should have got based on the model. Okay, and so now we say that the actual minus predicted equals a -8. So this was his predicted, so A minus 82 equals -8. If I add 82, we get some math here actually, add 82, I get A equals 74. So his actual was a 74. Okay? That's how you find the residuals. Okay? That is how you find residuals. So let's go and look at a couple of problems on our notes here, okay? This will be quick, okay? This will be quick, and then video 2 will be done. So residuals, least square rational line. In most cases, no line will pass through all the points. It's, you know, if you have a perfectly straight line, who needs to predict anything? Okay, but that's just, in real life, that's just not very common. Okay, normally your points are gonna be hopefully linear, but they're not gonna line up exactly, okay? A good regression line makes the vertical distance of these points as small as possible. So if I had this line like this, I wouldn't want to have my line there because that doesn't minimize those little residuals. I want the least squares regression line so that the distance between my line and the points is as small as possible. Okay, here it is again, observed minus predicted. Actual maybe, actual minus predicted, okay, they call it AP, so you don't forget the formula. When students calculate the residuals, interpret what they mean, okay, less than the predicted value. We talked about over predicted, under predicting, okay? So I'd like you guys to pause the video, I'm gonna do the same, I'm gonna pause the video, and then I want you guys to try this problem, okay? Here is your equation. Trying to think if you need anything else. It gives you the equation. I think we're okay. All right? Let me look. I know that sometimes I don't give you what you need. Predicted long distance equals that. Okay? And we have this. Oh, I need the actual run, right? I knew it was something. And in this one, in a previous problem, okay, we had 8.09, and then the actual one, the observed one, was 151. Okay? So I'm going to pause this video, and I'll be right back. Try it.